Today we will discuss a new topic and that is relevant to the testing the difference between the two variances. So we'll discuss that how you can test the difference between the two variances. Sometimes we are not interested in finding out whether the two populations differ in their means. Or rather, we are interested that if they differ in their variations as well. So, for this purpose, if researchers or the statisticians they are interested in finding out whether the two populations they differ in their variances as well, so we use another statistical test that is known as the F test. So usually F test is used to compare the two variances and the standard deviations. I can give you a few examples. Like, for example, you might be interested in finding out that whether the variations in the temperature for a certain month for two cities are different or not. In another situation, you can find out that whether there is any variation in the cholesterol level of men with the variance of the cholesterol level among the females or the women. So for these comparisons, F test is used. The formula for F test is quite simple, and this is simply a ratio of the two standard deviations or the variances. So there are two variances from the two populations, and the ratio of this these variances they compute a value that is known as the F statistics or as the calculated value of F test. The larger variance should be placed in the numerator, and the smaller variance should be placed in the denominator. And sometimes standard deviations are given in the question, or sometimes in the data standard deviations are given, so they should be squared to get variances. And that when you are conducting a two-tailed test, alpha is a split. And the third thing is, whenever you are using the F test, no matter if you are using a two-tailed test, only a right tail is used, because the value of F test, calculated value of F test is always greater than or equal to 1, and it will never be negative. So there are some assumptions when you use the F test, and there are two basic assumptions. Number one, that whenever you use the samples from the two populations, these samples or these samples should be drawn from the populations which must be normally distributed. And if they are not normally distributed, then this test should not be performed. Secondly, these samples that are taken, they should be independent of each other. So these assumptions should be considered in mind while using an F test. Now, how can you find the tabulated value of F test or the theoretical value of F test? For this purpose, you will use F table, and you need to know the degree of freedom. So for F test, since there are two populations, there would be two degree of freedoms. So degree of freedom in F test should be calculated by simply from subtracting 1 from the sample size from each population. Like for example, it should be n1 minus 1 and it should be n2 minus 1. So you can find out the degree of freedom for both the populations. And once you know the degree of freedoms for the population which is placed in the numerator and the population which is placed, the variance of which place in the denominator, you can easily find out the critical value of an F test, provided that you know the specific level of significance. So for example, you need to find out the critical value for a right tail F test when alpha is equals to 0.05. The degree of freedom for the numerator, which is abbreviated as DFN, are 15, and degree of freedom for the denominator are 21. So you can easily find out where these two values they intersect. In the table, the denominator degree of freedoms are to the left of the column, and the numerator degree of freedom are on the top. So you can find once you find the degree of freedoms for variances or the populations. So you can find out that where these two intersect in the table. So that is your value of the critical value of the F test. Sometimes you are not able to find out the degree of freedoms in the table. So there is a solution of that. And what is that solution? That you can take the closest value on the smaller side. For example, if the degree of freedom is 14, so this value is between the values of 12 and 15. So instead of going towards 15, you need to use the lesser value. So 12 should be used on the safe side. So this could be the easiest way to find out the degree of freedom. Now, as regarding the hypothesis, when you are going to define the hypothesis, you know that there are two possible tests, one-tail test and two-tail test. So when the test is the two-tail, simply the null hypothesis is with the sign of equality, and the alternate hypothesis is the sign of an inequality. For the right tail test, the null hypothesis again with the sign of equality that the population, they are similar in their variances as well, and the alternate hypothesis is with the greater than sign that this population, the first population, is greater in variance, they show greater variation than the second population. Or the left and the left tail test. In the left tail test, alternate hypothesis with the sign of inequality, particularly this with the less than sign, that the variance of the first population is less than the variance of the second population. So this is how you can define the hypothesis in these tests. So if your test is one tail test, then you need to define that you're going to test it towards the right tail or the left tail. But no matter what type of one tail test you use, critical region will always be formed at the right side, because the variation or the variances, they are never in negative. And because you are keeping the higher value in the numerator and the lower value in the denominator, so you will get the calculated value always in the range of 1 or greater than 1. Here's an example that there is a team of researchers who wishes to see that whether the variances of the heart rates in terms of beats per minute. It varies in a smoking or a non-smoking population, which a difference is tested. So two samples from these populations, they are collected and data are shown as this. So you can see 26 samples from the smokers and 18 samples from non-smokers are collected. And when the variation was calculated, or the variances in the heartbeat per minute was calculated, so the value was 36. Variance value was 36 in smokers and 10 in non-smokers. So is there any evidence to support the claim and use 0.05 level of significance? So what is the claim? That these two populations, they are similar in their variance, and it is a two-tailed test basically, because nothing is mentioned. So it's better that you use the two-tailed test. So state the claim and I state the hypothesis and identify the claim. So I just mentioned that because since null hypothesis is these two populations, they are similar in their variance. So the claim could be that these populations, they are not similar in their variances. So first we'll find out the critical value. So you can see, for finding the critical value, first you need to know the degree of freedom. So the numerator degree of freedom will be 26 minus 1. I just told you that we will keep the higher variance in the numerator. So the numerator degree of freedom is 36 minus 1 is equals to 25, and the denominator degree of freedom is 17 after subtracting 1 from the sample size. So for the two-tailed test, I just previously in previous slide told you there is a two-tailed test, so the alpha will be split and we'll use 0.025 level of significance in table H, means in F table. So when it was noted, so we found that the critical value is 2.56 at 0.025 level of significance. So after finding the critical value, the next step is to compute the calculated value. So when the test statistic was applied, so the calculated value was 3.6. So where this value lies, and this value lies in the rejection region, since 3.6 is greater than 2.56, which is a critical value. So since it lies in the rejection region, so we are going to reject the null hypothesis. And once we reject the null hypothesis, so we accept the alternate hypothesis, and we can say that there is enough evidence to support the claim that the variance of heart rates of smokers and non-smokers is different. So this is how you use the F test for finding out the variation or finding out the difference in two population variances.